let's conduct a hypothesis test about a population mean. So here in problem 19 on page 414, we have cans of Coke. Cola weights and volumes in Appendix B includes volumes in ounces of a sample of cans of regular Coke. The summary statistics are N equals 36, X bar is 12.19 ounces, and S equals 0.11 ounces. Use a 0.05 significance level to test the claim that cans of Coke have a mean volume of 12 ounces. Does it appear that consumers are being cheated? All right, so one of the things we're told here is that we are to assume that our data come from a simple random sample. Our sample size is over 30, so we know we've met the conditions of our hypothesis testing procedure, that of the central limit theorem. We're asked to claim that the mean volume is actually 12 ounces, which is what's printed on the can. So we're actually testing the claim that, well, the average volume is actually what's being advertised. So I'm supposed to write the claim down in symbols. Mu equals 12 ounces. The second statement was true and that's false, and this is the unique case where our claim becomes the null hypothesis. And then that other statement has to become my alternate hypothesis. Okay, now I need a test statistic, which here will be a t-score from the t-distribution and a p-value. I'll be making my decision here about the p-value. So I need to hit stat and go over to test, and this will be a t-test. I have summary stats this time. Mu naught is the claimed value in the null hypothesis, so 12. I have a sample mean of 12.19, a sample standard deviation of 0.11, and a sample size of 36. All right, now I need to pick that symbol from the alternate hypothesis. The mean is not equal to that claimed value mu naught, which up here I literally say 12, so this down here actually says the alternate hypothesis, and I'm ready to calculate. T is 10.364, very extreme, and then the p-value, 3.3 times 10 to the minus 12th. Well, they told me to use a significance level of 0.05, but this is lower than any significance level that I could even dream up. So we're going to reject the null hypothesis. I'll put a little exclamation mark there, though that's not necessary. Just felt like it here for this moment because that's the actual claim. We rejected the null hypothesis, we actually rejected the claim. There is sufficient evidence to warrant rejection of the claim that the mean volume is 12 ounces. All right, then we're asked, does it appear that customers are being cheated? And if we weren't thinking, we might say yes because we rejected the claim that so we're actually saying the cans don't contain 12 ounces of Coke. But a careful examination of the situation will show the sample mean is actually over 12. And that our test stat is on the high side. But this is enough information here that would say, well, the sample data would actually suggest that by saying not equal to, we actually mean more than. It's on the high side. It's like they're overfilling the cans. So I'd say no. It appears customers, on average, are getting more Coke. So no one's being cheated, everyone's actually getting just a little bit more.